Grade 12s, this is the last two examples for the geometry, and no more geometry will be put up on Google Classroom. There's only the converse and then theorem 4 and 5, which we'll do at some point when we get back from school before prelims. We won't be rushing it though, they're quite quick. So example 12 is just a bit harder. So is example 13. So again, they don't ask you which triangles you need to, well, they don't tell you which triangles to prove similar. You've got to figure it out, and there's just more information. So let's go through it. ABC is a cyclic quadrilateral. You know your cyclic quad theory. Chord BC is equal to CD. You can see it there. EFC is a tangent. All right. ECF is a tangent to the circle. Chord AB is produced to meet the tangent at E. So ABE, this one is not a tangent. It goes through the circle. AC and BD are drawn. Prove that BD is parallel to EF. So we've got to prove that those two are parallel. Now we can either prove it by alternate angles, corresponding or co-interior. But I'm seeing it'll be quite a nice thing to do an alternate there or an alternate there maybe. All right, so let's see what we've got. So we know we've got a tangent, so we've got tan chord at least. So go from the tangent into the circle, hit the circle. BC, where does BC go to the circumference at? D. All right, but if we have a look here, so we know that C1 and D2 are equal, but because of this isosceles triangle here, all right, that D2 and B2 must be equal, angles opposite, equal sides. So which means that we have B2 equal to C1, which makes a nice alternating angle like that. And then the lines are parallel. Alternatively, you could have gone from this direction and proved that tan chord equal there, and then like that. So you could have then had D2C4 equal. Okay, so you don't need to prove both. You can prove whichever one you see first. But the only way to prove parallel lines is through FUN, corresponding, co-interior, or alternate. So question A, we have BC equal to CD was given. Therefore, B2 is equal to D2, angles opposite, equal sides. But we said C1 equals to D2 because of tan chord theorem. Therefore, B2 equals C1. And so, therefore, we have BD parallel to EF because we have the alt angles equal. Now here we don't put the parallel lines after because we've put the parallel lines as the statement. It's not part of the reason, only when it's part of the reason. So now we asked about ratios. So CD to BE equals AD to CD. So that means that we have to work with two different triangles and prove them similar. But this one's a bit tricky because if we look, we don't have two triangles that fit the criteria and have two lots of CD. So let's look here. So we need a CD, which we've got over here. We need an AD, which we have there. So we can use that triangle. Then we need a BE, which is over here. And we need another CD. It's got to be in a different triangle or overlapping. So we can't overlap this triangle because if I try and do something like that, it's not going to be a triangle. But we know that BC and CD are the same. So our second triangle can have BC in it, and then later a BC can be substituted in for a CD because they are equal in length. So let's get started with our two triangles. So I'm going to work with triangle BEC. So that's going to be B1, C1, E. And then this triangle here, A2, D1 and 2, and C3. Okay, so now to work out what is equal where. So we at least know that we have some tan chord theorems. Okay, so let's go back here. So C4 is going to hit D, and so that can also extend to A2. So C4 is equal to A2. But we've already said in our previous discussion that C4 can also equal B2. Okay, but B2 equals D2. And we already also know that we also have alternate angles here. So we didn't even have to talk about B2. D2 and C4 are equal. And let's see what else. Okay, so, and then we know that this one and this one are equal because of alternate angles. So there we go. We've got, look, I've got a C1 in this triangle and an A2 with the same loop. So I've got a C1 and an A2 so far. Okay. Then let's see what else we can work with. Okay, this one's a tricky one. Just get rid of all this now. Okay, so we need either B or E. But B over here, if you look carefully, is the exterior angle of the cyclic quad. So it's going to be equal to D1 and 2. Okay, so that's a sneaky one. So then E and C3 are going to be equal by angles of a triangle. So let's try set this out for number B. So in triangle BEC and triangle ACD. Let's first go with the quick one. B1 is going to equal to D1 plus D2, exterior angle of cyclic quad. That's easy. Okay, so then 2 to get that C1 and A2 equal. So we know that C1 is equal to D2 tan chord theorem. Okay, so you can hopefully follow on the notes. I don't want to make this too small. So tan chord theorem, but C4 is equal to D2 because of alt angles, because we proved that BD is parallel to EF, so now it's part of the reason. But we also know that C4 is equal to A2 because of tan chord theorem. Okay, so C1 equals D2, but D2 equals D2 there. So C1 equals C4, but C4 equals A2, so therefore by conclusion C1 must equal to A2. Right. Just by logical extension. And then we'll have, for number 3, angle E equals angle C3, angles of triangle. So then now we're just going to figure out our order. So we have BCE, triangle BCE is similar to triangle DAC by angle, angle, angle. So then let's do our loops now. So white and white, blue and blue, let's do green and green. Okay, so now they say to us, our required to prove is that CD over BE equals AD over CD. Now we know that we need, if we've got two CDs, they need to be from two triangles, two different colors, but we don't have them, but we already know that we have a BC equal to a CD in the question. They told us that. Okay, BC equals to CD. So I'm going to set it out like this. I need a CD, definitely. So I've got a green CD. And then across from it, I should have either another CD or a BC, because that's what it's equal to. So I've got a BC, yes. Now I better hope I have the rest of it as needed. So we also need a BE, yes, I've got a BE in green. And I need an AD, yes, I've got an AD in white. So I've got a white from this triangle, white from that one. I've got a green from that triangle, a green from that. So 2 colors from 2 different triangles. So I need to now cut in here and say, but BC equals CD given. So therefore I've got CD. Let's just go back with the colors. CD over BE is going to be equal to AD over a CD. So this got replaced. And that's exactly what they wanted. So that's what the question asked for. Okay. So you just got to play around with these ones. For the last example, example 13, not too difficult. So it's just working with triangle. Well, in the diagram they tell you CD is perpendicular to AB, AF is perpendicular to BC. Prove that CE, so let's find a CE. CE over CF, got that. And CB, that whole side, to CD is that whole side. So I've got these 2 triangles here. So this one's really easy to prove. Just note that F2 is also 90 degrees. You don't have to prove it or say it. They gave it to us that whole line is perpendicular. So here, in triangle BCD and triangle EFC, firstly, we've got the same angle, angle C. They are common. It's labeled exactly the same. Not C1, C2, it's just C. Then I've got D1 equal to F2 given equal to 90 degrees. And so then angle B equals angle E1, angles of a triangle. So my order is triangle CDB is going to be similar to triangle CFE because of angle, 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 or equiangular. So then we do our loops. And now they want us to prove CE. So let's find CE is yellow over CF. CF is red. Must be equal to CB. CB, yes, is yellow in the other triangle. Over CD. CD is red. Okay, so we got these 2 from that triangle, these 2 from that triangle. So 2 triangles being used, 2 sides from each, 2 colors. And so the reason we know this is possible because I have similar triangles. Triangle CDB was similar to triangle CFE. All right. So that's question A. Question B is a little bit more challenging. We have proved that AE, so required to prove that AE squared equals CE times DE. Okay, so in this case, they also added if it is given that AE equals FE. So to get the AE squared, it means we've got an AE and an AE on opposite ends underneath, one on top, and a DE and a CE. But because of the statement that they told us that AE is equal to FE, it means one of the AEs could be an FE. Okay, so either one of them could be interchanged, and then we could work, so you could interchange both of them. So if you look at the picture now, AE is in a completely different triangle. So we needed AE. Let's go through it. AE. We need a CE, which we've got in the yellow. We need a DE, which is over here. So we're going to be using two new triangles, the red and the yellow. So we've got to prove these two similar first before we move on. So that's what makes this challenging. So in triangle ADE and triangle EFC. Let's go back now. Okay, so we have, that is also right angled. So we've got right angled. We've got here vertically opposite. So that's going to be quick and easy to work with. So ADE has E2 equal to EFC has E1, vertically opposite angles. Number 2, so we're going to have D2 is going to be equal to F2, given equal to 90 degrees. So then the last two angles, which is angle A and angle C, are angles of a triangle. Therefore, triangle EDA equals triangle EFC because of angle, 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 or equiangular. So then we do our loops. Colors are important here. So now we need an AE in two different triangles. So we've got an AE in green in this first triangle, but we can't reuse that AE, so we've got to use an AE at the bottom from another one. But if we look at the second triangle, there isn't an AE, but there is an FE, which are equal. Okay, so that's giving us the colors, green and blue. So let's check. We also need to have a DE. Yes, so DE is blue, and we need a CE, which, great, is green here. So we're taking green and green. We've taken blue and blue. Two colors, two from each triangle. But then we have to say, but FE equals AE given, I'm sorry, that's because of similar triangles. Triangle EDA is similar to triangle EFC. I feel like I've missed out one somewhere here. No, I've got it. Okay, so don't forget to put your reason in. So therefore it means AE can be doubled up here. Instead of an FE, we're putting an AE. So we still have our two different colors. So therefore, cross multiply AE squared is going to equal to CE times DE as the question wanted. Alright, so that's it. Here is your exercise 6, the even numbers on Google Classroom with the memo. Alright, again, remember, don't use your textbook exercise 6. This is a different exercise 6. If you want to use your textbook, that's just for extra for yourself. Good luck, grade 12s. This is the last of the geometry.